Hello, grade 9 students. Today we will start with a new lesson, Electrochemistry, Part 1, Oxidation Reduction. At the end of this video, you will be able to define oxidation, reduction, reducing agent, and oxidizing agent. Write and identify the oxidation and reduction half reactions according to the transfer of electrons. Have you ever seen a rusted coin or burning wood? Almost 1/3 of the chemical reactions taking place around us are of the form of oxidation reduction reactions. So what are oxidation reduction reaction and where do we find them? Before we start, electrochemistry means two words, electricity and chemistry. Electrochemistry is the branch of chemistry that studies the transformation of chemical energy into electric energy and vice versa. In the 1700th century, the word oxidation originally meant the reaction with oxygen. Where oxygen is added to a compound, this was because oxygen was first known as oxidizing agent. However, the definition of oxidation has become more general these days, including other types of reaction. Through our lesson today, we will discover more about oxidation reduction reaction. Let us watch this video that elaborates what happens in this chemical reaction. In this experiment, we are looking at the displacement reaction of metals. The chemicals that we will need are a beaker of copper 2 sulfate solution as well as a strip of zinc metal. What do you think will happen if we want to place this piece of zinc into copper 2 sulfate solution? Let's find out. We observe that as the reaction proceeds, the color of the solution changes from blue to colorless. In addition, a reddish-brown solid also formed on the surface of the zinc metal. How can we prove that what we watched in the video is a chemical reaction? We already know if there is a chemical reaction occurring or not by observing one of the signs of a chemical reaction. So number 1, list 3 signs for this chemical reaction. As you remember guys, the 4 signs of a chemical reaction are changing color, precipitation, release of gas, and exchange of energy as a form of heat and electricity. Then, what are the signs here? As you can see, a change in color, as you are seeing here, change in color from blue solution to colorless one. And as you see, the thermometer reads 15 degrees at the beginning of the reaction, then it reads 25 degrees after the reaction finishes. So the increase in temperature means there is exchange of energy in the form of heat. So the 2 signs or the 3 signs here, change in color, exchange of energy as heat, and formation of precipitate. As you see here, there is no precipitation here, but after the reaction ends, there was precipitation. Number 2, what happens to the temperature during the chemical reaction? So, as you see here, the temperature at the beginning of the chemical reaction was 15 degrees, then it becomes 25 degrees. So, as you see, the temperature increases. So, it increases. Number 3, what is the type of this reaction? As you remember, when a reaction releases heat, it's called exothermic reaction, and when a reaction absorbs heat, it's called endothermic reaction. As you see here, the temperature was 15 degrees, then it becomes 25 degrees. so there is release of heat, so the type of reaction is exothermic reaction. Let's see more what happens in this reaction at the level of the reactants. This is a beaker of copper 2 sulfate solution. The solution is blue due to the presence of copper ions. So what happened when we add a piece of zinc into the solution? The piece of zinc metal is made up of many zinc atoms which are packed regularly in layers. If we remember together from grade 8, we studied that each metal has its own reactivity. And zinc metal here is more reactive than copper metal. As a result, zinc has a greater tendency to lose electron and become zinc ions. This can be represented using the ionic equation as shown. Zinc atom loses 2 electrons to form zinc ions. Thus, we can say that zinc is oxidized. To recall our information now, let us repeat what happens at the level of zinc strip. So, Zn atom loses 2 electrons and become Zn 2 plus ions that are dissolved in the solution. Name the species that loses electron. So the one that loses electron, as we said, is zinc atom. Write its half equation. It was zinc. It loses 2 electrons to become Zn2 plus 2 electrons, and as we always say, in order to differentiate between the half equations, we can say that at the level of the species that undergoes loss of electron, so the species will be shy, يعني هتستحي من حالة, so it will hide the electrons that are lost at the end of the reaction. Now, where do these electrons that were lost by zinc atom go? Do they disappear? Let us see. Copper, on the other hand, is less reactive metal. Thus, it likes to gain electrons. This can be represented by the ionic equation as shown. The copper ion that is present in the solution takes the 2 electrons to form copper atoms. Since the copper ions gain 2 electrons, we can say that copper ion 2 is reduced. As the reaction proceeds, more zinc ions go to the solution and more copper atoms are being deposited into the surface of the metal strip. So, we can say the more reactive metal, Zn, can allow the less reactive metal, Cu, to change its place from the solution to the metal. To recall again our information, so what happens to the copper ions in the solution? Copper ions gains the 2 electrons that were lost by zinc and becomes copper atom where they make a brown deposit on the strip. Name the species that gains electron, so it's copper ion. Write its half equation. Copper ion gains 2 electrons to become copper atom. Also, as we said, when the species gains electron, it will be proud of itself and put the electrons that are gained at the beginning of the reaction. What is the type of each half equation? There are 2 types of half reactions. Oxidation half reaction. Oxidation is a half reaction during which a chemical species lose electrons. Oxidation is a loss of electrons. It's represented by the following half equation. X gives Xn plus an electron, or Yn minus gives Y plus an electron. The second type is Reduction half reaction. Reduction is a half reaction during which a chemical species gain electrons. Reduction is a gain of electrons. It's represented by the following half equation. X and plus an electron gives X, or Y plus an electron gives Y n minus, where n here is the number of gained or lost electrons. If reduction half reaction occurs in case of gain of electron and oxidation half reaction in case of loss of electron, assign the type of each half reaction 1 and 2. Equation 1, Zn gives Zn2 plus 2 electrons, and equation 2, Cu2 plus 2 electron gives Cu. Here in equation 1, see that the number of electrons are hidden at the end of this reaction. This means that there is loss of electrons, so the type of reaction is oxidation half reaction, whereas in equation 2, the 2 electrons are present at the beginning of the reaction, so there is gain of electrons, and the equation is called reduction half reaction. Note, oxidation and reduction always occur simultaneously. In order to remember oxidation and reduction reactions, you should study two words, Leo and Ger. So you should study Leo says Ger. Leo means loss of electrons, means oxidation half reaction, and Ger means gain of electrons, means reduction half reaction. Is used in oxidation reduction. Substance gaining electron undergoes reduction reaction. We call it reduced substance or oxidant or oxidizing agent. So the substance that undergoes reduction half reaction, it's called oxidant, oxidizing agent, and reduced substance. While the substance that is losing electron undergoes oxidation reaction, it's called oxidized substance or reductant or reducing agent. So the substance that undergoes oxidation half reaction, we call it reductant, reducing agent, or oxidized substance. Here, species A loses electrons to give them to species B. So A loses electron while B gains electron. A is oxidized while B is reduced. A is the reducing agent or the reductant, and B is the oxidizing agent or the oxidant. Here we have two reactions. The first one, Zn gives Zn2 plus 2 electrons, and Cu2 plus 2 electrons give Cu. Indicating the above equations, the reductant, the oxidant, the reduced species, and the oxidized species. To start with the reductant, as you should study that the reductant is the species that loses electron, means undergoes oxidation half reaction. So here, the first one is the oxidation half reaction. So the species that is reductant is zinc atom. The oxidant, as you should study that oxidant is the species that gains electron. So it undergoes reduction half reaction. So it means copper ions. The reduced species. The reduced species is the species that gains electron, so that undergoes reduction half reaction, which means copper ions. And the oxidized species is the species that loses electrons, so it undergoes oxidation half reaction, which means zinc atom. Application. Match the following: oxidation, reduction, oxidized species, oxidizing agent, reductant, and reduced species. So stop the video, try to solve this application alone, then turn on the video. The species that undergoes oxidation, we call it oxidized species, and also we call it reductant, while the species that undergoes reduction half reaction, we call it oxidizing agent and reduced species. Application: indicate the type of the reaction, reduction or oxidation in the following equations. Remember the two words Leo and Ger. Al3 plus 3 electrons give Al, Ag plus 1 electron give Ag, O plus 2 electrons give O2 minus, Al gives Al3 plus 3 electron, and Mg gives Mg2 plus 2 electron. So pause the video, try to solve these equations alone, and then turn on the video. Al3 plus 3 electron gives Al. So as you see that the electrons are at the beginning of the reaction, so there is gain of electrons. So the type of reaction is reduction reaction. Reaction number 2, the one electron is at the beginning of the reaction, so there is gain of electron. So the reaction is called reduction reaction. Number 3. The two electrons are at the beginning of the reaction, so this means that there is gain of electron, so the reaction is also called reduction reaction. Here in equation 4, the electrons are at the end of the equation. This means that there is loss of electrons, so the type of reaction is oxidation reaction. And the last one, the two electrons also are at the end of the reaction. This means that Mg loses electrons, so it undergoes also oxidation reaction. To sum up, there are two species that one of them loses electron and the other gains electron to make something called redox reaction. The first one that loses electrons undergoes oxidation half reaction, and this reaction is in general as X gives Xn plus an electron, or Yn minus gives Y plus an electrons, or the other element that gains electrons undergoes reduction half reaction. This reaction in general is Xn plus an electron gives X, or Y plus an electron gives Yn minus. So the species that undergoes oxidation half reaction is called oxidized species, and the species that undergoes reduction half reaction is called reduced species. The species that also loses electrons is called reducing agent, and the species that gains electrons is called oxidizing agent.